Good afternoon, fifth period. How are y'all doing? Good. I hope you enjoyed the Getting Tricky With It song. If you did, if you liked it and you want to hear it again, use it as a study technique. It's on my YouTube channel's playlist for you guys, the Geometry Videos playlist. So feel free to go and check that out. I didn't make it up at some other high school. I don't know where this high school is, but this is what their math teachers do, and it was pretty cool. So make sure that you all have a hero with you today. I'm pulling my favorite today. So mine. You lost all respect for me? I'm sorry. He's one of my favorites. One of.
Who's your favorite?
Any favorite?
Depends on the day.
I don't know what favorite.
It depends on how I'm feeling. All right, let's start off with a recall moment. What was the ratio for cosine?
Opposite over.
Beautiful recall for sine, opposite over hypotenuse. That's what we did yesterday. Lovely. Go back Friday and pull up cosine. SOHCAHTOA can also help you out here. Here was sine, opposite over hypotenuse. The C stands for cosine, so cosine needs to do what in the hypotenuse? Adjacent, that's what that A stands for. So, nicely done. Adjacent over hypotenuse. Beautiful. Let's go ahead and get started on the first example for the day. This example comes to you from page 139. Please draw a right triangle. Yes, you can make this right triangle almost as big as you want. Make sure you have at least half the page, half of your workspace left over so that you can get the rest of the notes. Mark your right angle. I need 3 letters.
L.
G.
G.
K.
P.
All right, LGP. I need 3 numbers, all positive. Go.
4.
27,
10.
4,
89.
89. And I needed something bigger than the 27.
No, it's not positive.
It's totally a positive number. It's not a negative number.
Oh.
Okay.
I'm thinking
It's okay.
something else.
You're thinking even.
Yeah.
You were thinking even. All right. Yesterday, the directions read, find the sine. Today, the directions are going to say, find the cosine of G and cosine of L. Write as a fraction and as a decimal to 4 places. Take your paper and this far edge right here, I'd like you to fold it over to your big margin, okay? So you're going to fold your paper over, and I'm going to zoom out a little bit so that you can see what I did, okay? We're folding it over. We don't have to crease the whole paper. We're just doing this kind of portion right here where we're going to write. Okay? I'll zoom it back down so we can continue reading it. There you go. Okay. Gonna trace over this line just for a few rows there. Trace over the fold. And we're gonna start with the cosine the cosine of theta, which from our recall was cosine of theta equals, beautiful, the adjacent over the hypotenuse. Please notice that now I am abbreviating those side names. Gentlemen, put it away for now. Thank you. Thank you. Appreciate it. going to substitute for what I have. The first one says cosine of g. So the cosine of g equals the side adjacent to g divided by the hypotenuse. We're going to use the same sort of trick from yesterday when we were finding the sine. We're going to put a pen and cover angle G. But this time, to find the adjacent, it's not the side that's being pointed at, but it's one of the two sides that's next to the pen. The big question here becomes, which one's which? So you have to identify the hypotenuse first, which is 89. It's always the biggest and the one across from this right angle. So 89 is the hypotenuse.
Is it like a little A squared?
Yeah, it's very much related to the a squared plus b squared thing, yes. I'm glad that you saw that. Go ahead and write that over here, if you would, to yourself. You've got a connection that you made, kind of related to that a squared plus b squared thing, the Pythagorean theorem.
The same thing, you know.
It's not exactly the same thing, but it is definitely related to it somehow. Yeah, let's do a little chain that looks like an infinity sign. That doesn't work. How do we show that we've hooked? That we're hooking into something. Maybe we'll draw a little fish hook. There we go. Does it look like a fish hook? Sort of. Hook to the Pythagorean theorem. Pythagorean theorem, which is that a squared plus b squared equals c squared thing. It's kind of related to it. Cool. All right. Since this is a fraction, and they wanted it in a fraction form, is it in reduced form? Is it in simplest form? Do these two things have a factor in common? I don't know, but I need a hero. Yep, to tell me now. Is this fraction in simple? Yeah, no, it's not going to work today. It's not happening. All right, so what I'm going to do is, these particular calculators, fantastic for this. I'm going to do 27, I'm going to divide it by 89, and I'm going to hit enter straight, and it'll give it to me as a fraction. I'm going to scoot it over so that it becomes in focus. Notice how the fraction didn't change? It's totally in simplest terms. All right, so our fraction is in simplest terms, so let's go ahead and get, excuse me, the decimal for it. So again, going to go to my superhero. I'm going to scoot my paper over. And from here, I'm going to do Control Enter, so it'll give it to me as the decimal. 0.3034, because we're rounding. Confirm for me, please. Yes? Okay. All right, you're going to do the exact same thing, but for the other angle. You're going to do that for the cosine of L. Take a few moments to do that. Go ahead and get started. I will catch up in just a few seconds. All right, that's what I got. Double check yourself before you wreck yourself. Yes, sir. All right, seems okay? Thumbs up, this was super easy. Thumb sideways, I kind of got it, but I'm going to stare at my notes for a little bit. Thumbs down, you're completely lost. And if you don't vote, I'm going to assume you're thumbs up. Okay, cool. So we only have a few that are thumbs sideways. which means you're just going to keep looking at this. Come back and see me right after lecture if you want to just verify that you have understood it. Let's do the last example for the day. This is page 140, number 13. And as promised, the bell will ring. As promised, we're going to do the exact same one that we did yesterday during lecture, but now we're going to use the cosine to find the information. So this is the exact same setup from yesterday. Excuse me. And I'm going to use some of the information from yesterday, which was this. Oops. Okay. So I'm going to write in the answers that we got yesterday. So yesterday we said that B was that value and A was this value.
Miss, is that a 57?
It is a 57. I'll rewrite it. I'm trying to write my 9s a little differently. I've noticed that they're looking too much like the little letter A, and I know that. So I'm trying to write them a little differently. Hopefully it helps out. Let me know if it really doesn't. All right. So that's what we got yesterday. And then over here, going to really very quickly write down what we did to remind ourselves. We're looking at what we did yesterday. Yesterday we took the sine of 57. We set it equal to the opposite over the hypotenuse. We converted the value of the sine of 57 into a number. We used our calculator for that. We multiplied both sides by b or cross-multiplied, whichever way, you get the same thing. And then I divided both sides by that decimal, and it gave me this for b. To find a, which we did do yesterday using sine, we had to first figure out what the measure of this angle was right here. We're going to go ahead and call it theta. And we got that by taking 180, which is our triangle angle sum, and subtracting the measures of the angles that we already knew. And this gave us an angle measure of 33 degrees. Now that we knew what the angle of this was, we put it back into our sine, and again with our ratio. But this time, we already had b, and so again we calculated the sine of 33 and did our substitutions. And then we did our multiplication. And when we were done, we got that. Sound familiar from what we did yesterday? Now this is the shorthand. You know, yesterday took a lot longer and a lot more paper because we showed a bunch of work. But this was just kind of reminding you the highlights. All right. Let's say we start with this angle 57. Okay? And if we want to use the cosine of 57 degrees, we need the adjacent over the hypotenuse. In this case, the adjacent is A, and the hypotenuse is B. Neither one of those have any measurements, and so we're kind of stuck. We don't know really what to do here. However, we could use this information right here. I need to find a highlighter. Right here from yesterday, using the sine of 57, and use this hypotenuse already. Okay? This is so that we don't have to go figure out what this angle measure is. So we're going to do the substitution with the hypotenuse that we got from yesterday. 16.6925. And we're going to convert this number now. So go into your superhero, and find the decimal number for the cosine of 57 degrees.
57?
57 degrees, yes, sir. The cosine.
I got 0.83.
You got 0.83. Did you do 57 divided by this thing? Do cosine of 57 degrees. It's in the same place as the sine function from
I
yesterday.
got .5446.
You got 0.5456. Notice how similar it is to the sine of that complementary angle. Yeah. That's kind of an important moment. So hang on to that moment. Note, the sine of 33 degrees is equal to the cosine of 57 degrees. Oopsie. Sorry. This could be something interesting for later. Interesting. And you can jot down your feelings about that right now. If you've got that I wonder why in the back of your head. Or if you have a thought as to why, you know, what your reason, go ahead and jot that down. All right, now we're going to multiply both sides by this number down here. Or cross multiply. Right? Either way is going to get you to the same place. So this side is going to become this. And this side is just A. Give me the number. Do the multiplication. $9.08907. Look at that compared to what we got when we used the sine function. They're not exactly the same, but they're pretty darn close. Right? They're the same up to 9.089. That's where it gets different. They're the same up to 3 decimal places. That's pretty darn good. Any questions on how you use cosine to figure out side lengths? Feels pretty simple? Simpler now than figuring out how to do it with sine yesterday was, right? Right, because we're building on it. And so the main question that you guys have to wrestle with when you're doing your practice and when you're going to have to apply these later on is this. Which one should you use? And the honest answer is whichever one you have the information for. And it doesn't matter because clearly you get the same results. It just depends on what you see, what you have the information for, and what you're actually looking for. Use whichever one is easier for you in the moment, depending on what you have. Thanks. Yes, ma'am. You have a science thing at 12:30. You know what? It's